Let's look at some examples now where instead of just being given the vague, oh, it's positive or negative for our leading coefficient and even or odd for our degree, we're going to be working with real equations with numbers. So in this particular equation, let's define our degree first because that's going to lead us to the leading coefficient. So our degree is our biggest exponent, which is this 4. So we can say that the degree is 4, which means we have an even function. But we don't know if it's even with arrows pointing up or down until we look at our leading coefficient. So our leading coefficient is this negative 0.05. So a negative 0.05 is a negative number. So remember, if it's negative, that defines that on the right-hand side, we are going down. So down on the right. Our degree being even means that they are going the same direction, so we're also going down on the left. Let's go ahead and write that in math language. So on the left, as x approaches negative infinity, because that's what it always approaches on the left, our f of x for our function is also approaching negative infinity. On the right-hand side, we know that x is headed towards positive infinity. F of x is headed towards negative infinity. It's approaching negative infinity. So this is our solution here of describing our end behavior in words versus this describes our end behavior in symbols, just the down arrows. All right, let's look at another one. We want to first identify our degree, which will then lead us to our leading coefficient. Our degree is 5, so 5 is odd. Remember, on degree, we're looking odd or even. And then our leading coefficient is the 3 in front of that term, and 3 is a positive. Positive lead coefficient tells us that our arrow is going up on the right-hand side, and the fact that it's odd for our degree tells us that the left arrow must be going opposite, left as it's going down. All right, let's write this in our words and symbols. So on the left, as x is approaching negative infinity, f of x is approaching negative infinity this time. And on the right-hand side, as x is approaching positive infinity, which is what always happens on the right, x is going towards positive infinity, our f of x is headed towards, in this case, positive infinity as well. One more example, and as we look at this one, we want to be super careful. You always need to look at all of the terms and be sure that you're picking out your biggest exponent. So in this case, the biggest exponent is hiding here in the middle. It's not in that first term, but that is still our degree. Doesn't matter if it's in our standard form or not, degree is always defined by the biggest of our exponents. All right, so degree is 3, and that is odd. So we know our arrows are going to be opposite, but which direction goes with which? We have a coefficient of basically a -1. So a leading coefficient of -1, because we would have an implied 1 there in front of the x, is of course a negative number. And so that means that it's a negative direction going down on the right-hand side. If that one's going down, then because we are odd and means opposite, then we are going up on the left. So we can talk about the left-hand side. As x approaches negative infinity, then f of x is approaching positive infinity for this one. And on the right-hand side, as x approaches infinity, our f of x is approaching negative infinity.